Hey guys, so we are going to continue with some probability problems, but they're a little bit more involved now. We're going to work on some problems that are what we call multiple event probability, and that just means that we have to pay a little bit more attention to what's going on here, and it's just a step above the basic probability questions we've been doing, and you will see why that's the case as soon as we get into some examples here. What I have here are some examples directly from the MyOpenMath practice problems today so that you can see exactly how to do those when it's time for you to do those practice problems on your own. Okay, so let's start with question 1. We have a hat rack with 5 colors of hats. We have 9 white, 11 black, 7 gray, 15 red, and 6 purple. So we then found out we lost 5 hats, 5 white hats for some reason. And so now, considering that, what is the probability that if we pick a random hat off the rack, we get a black one? So a couple things we have to consider here. One, it's always a good first step to figure out how many total hats we have. All right, so to find that, we just have to add up all the amounts of all of our hats. So we know that the total must be 9 plus 11 plus 7 plus 15 plus 6. And all I did was I added all of these numbers. And this is going to give me a total of 48 hats. All right. So now that I know my total hat amount, okay, this gives me a good starting point. So now let's take into consideration the fact that we lost 5 hats. Before we grab a hat at random, we lost 5. So a new total is going to be 5 less than our original. Right? So now we have a total of 43 hats. So black hats, we have, let's see, 11. We have 11 black hats. So we know that there's 11 black hats and there's 43 total in our new situation. So to find this probability, we just want to say, okay, well, 11 over 43 is the probability of picking a black hat after we lost 5. It has come to my attention that on MyOpenMath, it just wants the decimal, so I'm going to show you guys how to handle that. On a test and stuff, I wouldn't care, decimal or fraction, doesn't matter to me, but on this particular hat problem, MyOpenMath is only accepting decimals. So I did 11 divided by 43, and I got 0.25581, all those numbers. So I'm just going to go ahead and call this 0.256. I'm rounding to 3 decimal places, so 0.256 is going to be just fine. Okay. So I'll just put that here, and that is it for that problem. All right, on to number 2. Let's say we have a jar that has 3 red balls, 4 white balls, 7 yellow balls, and we want to find all of these different separate probabilities. So let's start with finding the total number of balls. That's, again, always a good first step. So we've got 3 plus 4 plus 7. I just added all of the balls together, and this gives me a total of 14. So we have 14 balls in there to begin with. So the probability that a red is drawn, we would need to discuss how many red balls there are over the total. So we know that there are 3 red balls, and there's 14 total balls. Okay, and so my probability of drawing a red ball randomly is 3 out of 14. In this problem on MyOpenMath, they actually are accepting fractions. So if you put fractions, it's fine. If you put decimals, it's fine. This particular problem was created in a way to accept both. All right. So now let's look at if we removed a red ball, what's the probability the next one will be white? So now, here's the thing we have to pay attention to. Okay, at the end of the day, we are looking at I'm struggling to pick a color here. We're looking at, oh, it's a terrible color choice, sorry. We're looking at white balls over the total balls, okay? Or marbles, I guess. So here's the deal. There's a total of 4 white balls. So we know that 4 is on the top. But the total, this is where you have to be careful. Originally, we had a total of 14 balls in the jar. And now we first removed 1 red. Okay, so this becomes 1 less than 14, right? Because we started with 14 and we took 1 away, so that's why I'm showing you this subtraction. So really, the probability of drawing a white one will be 4 out of 13. 4 out of 13. Okay, and one more here. If you first removed 1 yellow ball, what's the probability the next will be a yellow 2? So here's the deal. In this situation, we still have to remember that we started with 14, but if we removed 1 yellow, then we ended up with 13. So we have a total of 13 on the bottom because we removed a yellow. But I'm going to show all the pieces here. So we started with 14, we took 1 yellow away, so that's our new total at the bottom. And here's the other thing. We started with 7 yellows, but we took 1 out before we're testing the probability of another yellow. So really, this one will be 7 minus 1 because we took 1 out. All right. So this tells me that 7 minus 1 is 6, 14 minus 1 is 13. This tells me that my probability of this event is 6 out of 13. Okay. And again, that's because we started with 7 yellows, but we took 1 out. And then that means we took 1 out of the total as well. So we have to show that in our numbers. All right, one more problem here. We have a bag of M&Ms now, 6 red, 2 green, 3 blue, and 5 yellow. So let's start by finding the total M&Ms. It always helps to have a total number to work with in the beginning. So we have 6 plus 2 plus 3 plus 5. And this gives me a total of, let's see, 16 M&Ms. All right, so now let's take a look at this. If you already drew out a blue, what's the probability of drawing a yellow? So we know that if we drew out a blue, now the total on the bottom becomes 1 less than it was originally. So let's start with my setup here. We know that if we're doing a probability of a yellow, we're going to need yellow divided by the total. Okay, so in that case, we know that there are, let's see, 5 yellows. So 5 yellows over the total, but we drew out a blue M&M, so that means that the total now is our original total minus 1 because we took 1 M&M out. So that tells me it's 5 out of 15. And this problem on MyOpenMath also accepts fractions. It's only number 1 that won't accept your fractions. This will accept fractions or decimals. So if you want to put the decimal, that's fine. If you want to put the fraction, that's fine as well. All right, so that's our probability there. This can also be written as 1/3. You can put the simplified fraction as well. All right, so number 2, what's the probability of drawing blue or green? This is a completely separate problem from number 1. See how I said 3 different situations, so don't even take this first problem into consideration. So blue or green, okay? That means that we're content with drawing either of those. So the probability of drawing blue, well, there's 3 blues. So let's first represent what we're looking for here. When we're looking for an OR probability, we have to add them. Okay, so we got to add the blue and green and put them over the total. So, oh goodness. The blue, there are 3 blues and there are 2 greens. So we have 3 plus 2, and the total is still 16. That didn't change at all in this situation. So we end up with an answer of 5 out of 16. Okay, and that's it for that one. Last one, if you already drew out a red, what's the probability of another red? Okay, this is kind of similar to a problem we did on the last one, and it's also kind of similar to number 1 over here. So now we are dealing with red probability. Okay, but here's the thing we have to be careful of. Originally, there were 6 reds, but we took 1 out. So while there were 6 before, we have to subtract 1 from there. And also, there was originally a total of 16, but because we already took 1 M&M out of there, we now have to subtract 1 from 16 from the total as well. That's kind of weird. All right. So that tells me that my chances are 5 over 15. So same answer as number 1. And again, you can put decimals on this one too. This ended up being the exact same answer as this first one. All 3 of these are valid answers. Okay, and that is all. Hopefully that should be enough information for you guys to work through the problems on MyOpenMath. I did 1 of each type. Let me know if you have any questions.